Good morning, children. Today we will discuss about mutual impedance of antenna. Let us go with the presentation. Mutual impedance of antenna. Already we have discussed about self impedance of antenna. In the case of self impedance of antenna, we have assumed the antenna is a lossless antenna and it is isolated from other objects and ground. But here, if you consider the large antenna systems, if we consider the large antenna systems, any antenna may be placed very close to the other active antennas. So in such cases, antenna terminal impedance is not simply equal to the self impedance. Why? Because so here, if we consider the self impedance of antenna, we have assumed only isolated from other objects. That's why here we left in the self. Because of that condition, we have obtained the self impedance of antenna. But in the case of large antenna systems, we have to place the antenna to the other active antennas. So in such cases, antenna terminal impedance is not simply equal to the self impedance of antenna. So that impedance is nothing but the mutual impedance of antenna. That means here we have to place the antenna for which is close to the other active antennas. So at that particular time, the impedance is not simply equal to the self impedance of antenna, but it is the mutual impedance of antenna, because due to the currents which are flowing in the active antennas, the voltage may be we can observe the induced of the voltage in the another antennas. So based on that concept, this is the mutual, we will obtain the mutual impedance of the antenna. So let us discuss here. So before we are discussing about the mutual impedance of antenna, let us consider the coupled circuits with two circuits. So here, this is the example which we are seeing. Before we are going into the antennas, we will see the so how the voltage is induced in the circuits because of the another coupled circuit. So here let us consider here. So this is the circuit one. So this is the representation of voltage induced in the coupled circuits. So this is the, let us consider, this is the circuit one with current I1, and this is the circuit 2. So here the current is flowing in the circuit 1. So because of the current which is flowing in the circuit 1, voltage is induced in the circuit 2. So here, this is the circuit 1, which is current is flowing in the circuit 1. We can observe the voltage induced at the terminals of the another circuit. Here, these are the terminals. So voltage is induced at the terminals of the circuit because of the current flow in the circuit 1. So that's why here we have voltage in the circuit 2 because of the current in circuit 1, V21. Here we have represent here. So this is, if you consider, so this is the circuit 1, this is the circuit 2, and here current I2 which is flowing in the circuit 2. So because of current in the circuit 2, so voltage is induced at the terminals of the circuit 1. So voltage in circuit 1 due to the current in 2, circuit 2. So V12. So this is a representation of voltage induced in the coupled circuits. So this is the concept, the same concept which we can see in the case of antennas. So thus the mutual impedance of the coupled circuit is defined as negative ratio of the negative ratio of the voltage induced at the open terminals of one circuit to the current in the another circuit. So here mutual impedance of the coupled circuit is defined as negative ratio of voltage induced at the open terminals of the circuit to the current in the other circuit. So here mathematically we can write Z21. So this is a mutual impedance. So Z21, which is equals to negative ratio of voltage to the current. So V21 by V1 I1. That means here voltage induced in the circuit 2 because of the current in the circuit 1. So V21. So Z12 equals to minus V12 by I2. So that means here voltage induced in the circuit 1 because of current flowing in the circuit 2. So let us consider the two antennas which are kept very close to each other. So in the same concept, like circuits, how we have find out the mutual impedance. So the same concept also here we will discuss. So here we have to, let us consider the two antennas. Those are very kept very close to each other. So such antennas may be called coupled antennas. We can say the antennas, whenever we are keep very close, the antennas are nothing but coupled antennas. we will see. So these are the antennas, coupled antennas. So this is the antenna 1 and this is the antenna 2. So this is the current I1 in the antenna 1, and here because of this current I1 in this due to this antenna 1, voltage is induced at the terminals of the antenna 2. In the same way, so here current because here current is here we can observe in A2 here, because of the current in A2, voltage is induced at the terminals of A1. So here V1. So voltage in antenna A1 due to the current in A2. So V12. So here also V21. So these are the coupled antennas. So here uh, mutual impedance of antenna is given by Z21 equals to negative minus V21 by I1. Already we have seen like here in the circuits same. So here, and Z12 equals to minus V12 by I2. So here this is a mutual impedance, Z12 equals to minus. So voltage in antenna 1 due to the current in antenna 2 by I2. So V12 by I2. So but according to the reciprocity theorem, we can write the mutual impedance of antenna as Zm. Here M represents the mutual impedance. So Zm equals to V21 by I1 equals to V12 by I2. So here the mutual impedance depend upon magnitude of induced voltage, phase difference between induced voltage and input current, tuning conditions of the coupled antennas. So while we are tuning, we will obtain the this mutual impedance of the antennas. So phase difference between induced voltage and input current, magnitude of induced voltage. So mutual impedance depends upon these three uh, quantities. Thank you, children.